heat transfer modes, and that's in chapter 2 in the book. We said there's conduction, convection, and radiation. We said conduction is through solids, convection is through fluids, the air and water. If it's natural, then it's moving by the law of buoyancy. Hot air rises, cold air sinks. Hot water rise, cold water sinks. So it's moving constantly using the buoyancy effect. Otherwise, we can use forced convection, where we put a fan or a pump. If we have a boiler, and the boiler has hot water, the water eventually will go up to the tube, to the radiator, but it will take forever. So it will take very, very long time. So we have to force the water through the tubes all the way to the radiators. Why do you need to know? You want to know how to transfer heat from one place to another quickly. And the simplest example is the ovens. Ovens has been there since I don't know when, they start cooking, but they still have some improvement on it. They say we have convection oven, which is basically just hot air with a big fan in the back. Now they have radiation. Now they have something called induction ovens. So they're trying to use all modes of heat transfer into the food. For us, we're doing the same thing. We're trying to use all modes of heat transfer to move the heat from the source to the living space. So a mix and match will be good, and the purpose is to get the heat to the living space as soon as possible and with the least intrusive way. Meaning, you don't want something very big and bulky, and you don't want something very noisy. I lived in an apartment where the AC is central, but every time it comes off, the whole building shakes, and it's way too cold that you wake up because it's too cold. Then it goes off for a few hours. So it's like a lot of cycling, and it's very, very uncomfortable. And there's no way to turn it on and off. I remember at some point we used to put magazines on the fence to prevent the cold air from coming. So it was, I don't know how many zillion tons or whatever. So you freeze, then you wake up, and this is how you get sick.
Yeah.
This is how you get sick.
Sweating.
Yeah, sweating and like shocking your body. You know, if you shock your body usually, how do you get sick? Let's think about it. Why do you get a cold when you're going outside? Virus. You have viruses and bacteria in your lungs and your throat all the time, but your body is fit, so you can fight it off. And it's not the right temperature for the bacteria to thrive. Your body is what temperature? 97. So that's not a very good environment for the bacteria. When you go in the cold, if you're not covered up, if you're losing heat, your body temperature will drop, and the bacteria will start to thrive, and also your body will become tired and sick, and your temperature will drop, and the bacteria will take over. So bacteria has to take over. Sometimes if you're fit, if you're healthy, your body can fight viruses because they're all over the place. So again, being sick is also a function of ups and downs in heat. Also with humidity. If it's too humid, it's a good environment for the bacteria, which means also you can have breathing problems. If it's too dry, your body is not, your body tissue it's too dry, and you might feel itchy. And again, the moment your body loses the ability to fight germs, it's when you get sick. And did you notice that if you lose sleep for a few days, you're prone to get sick faster because your body is tired and it's on survival mode, and you can get sick quickly. So again, being in the right temperature will always keep you fit and healthy. Heat transfer fluids, we talked about air. Again, we're living in air, so it's easier for us to heat the air because you feel it right away. Or we can use water, but with water, again, we're not fish. So when you use heat transfer fluid as water, you have to convert that to air, which means you're gonna run the water through tubes, and the tubes should have air circulating around them. And the air is circulating around it to heat the air. So eventually you want to heat the air because that's a living space. We can use glycol or antifreeze as a mixture, and that is good for what? For this kind of weather. Yeah.
So what's in the glycol that prevents the water from freezing?
Alcohol mixture with some with ethanol and some kind of trimethylene, which it will freeze, but at minus 50.
That's what they use in vapes, man.
Huh?
That's what they use in vapes.
Yeah. No, that's that glycerin.
Different chemical.
Glycerin. I think it's glycerin. Yeah, you cannot smoke that.
Polyglycol.
Yeah. A lot of chemicals. So, do you notice if you have a bottle of alcohol, you can, like liquor, put it in the freezer, it does not freeze. Because the freezer is set at 12 degrees or 10 degrees Fahrenheit. So, it did not reach the freezing point. So, the same thing goes with the antifreeze. It will not freeze until like minus 40, minus 30 Fahrenheit, which means that you have more time to freeze it. And also, it boils faster than water, so it has different properties. What is the disadvantage of using glycol? It's lighter weight. It's not going to have the same thermal capacity or heat capacity. It does not conduct heat as well. So it has advantages and disadvantages. So that means if you have a system with glycol in it or antifreeze, you might have to resize the pump and resize the expansion tank. They expand differently than water. So that's something you have to think about. Also for if you use antifreeze in your car, what happens if you don't use antifreeze in your car? You use just regular water. It's freeze. Besides that, what if you live in Texas and you put antifreeze?
It'll definitely overheat.
It will rust faster. So they have agents that prevent rusting. If you use, if you're in a warm climate and you do not need to use antifreeze, you will rust your engine and your radiator quickly. Also, the antifreeze has some lubricating agent that will lubricate your pathways and your pipes and also your pump. So it has advantages and disadvantages. What is that? Another disadvantage is the disadvantage of glycol in the house.
It tastes really good.
It's toxic. It tastes very good for animals. For dogs and cats love it.
Sweet.
Dogs and cats love it. So if your car is leaking into your garage and you let your dog there, he might not sweeten anymore. He might not make it. What is it? What does it smell like if you burn glycol?
Sugar.
Maple syrup. If you smell maple syrup in your car, you know you're leaking antifreeze into your vents.
You did that or one of your groceries didn't make it.
If you have syrup. So I think
got
that's
that scissor.
huh? Say what? Did you watch the Seinfeld episode when they're gonna put pizza in the engine? They don't have the space, so stop putting food under the hood. So what about non-fluid transfer? If we don't have fluid, what are we gonna use? Conduction, we're gonna use some fins and pins and wires. There are ways to conduct using solids. And materials are getting more and more advanced. You get some materials with really, really good heat transfer ratio. And I told you about somebody now that are working on geothermal using graphite rod. You dig a hole in the ground, you put like an array of rods, and they will transfer the heat from the ground to the surface for free. Because the only drawback for geothermal is the pumping power. You always running the pump or the inducer fan, and that will run you down power. If you have solid, the solid will conduct efficiently. Copper is a good idea, but again, it's going to be really expensive, and I don't think you'll have the same heat transfer as graphite. Think of your pan. If you have a frying pan, usually the handle is designed in a way that you can hold the pan and it's cold to touch, even if it doesn't have a wood or rubber handle on it. It should go through it. Infiltration, we talked about that plenty. It's the air exchange. So what's happening is you're sacrificing some of the air in your space and you bring new ones in. And we can test for that for blower door testing to know what is the filtration rate for your house. There is a requirement for air exchange in a house. You don't want the house to be airtight. What is that as general rule per person?
Is it
15 CFM. 15 CFM, that's cubic feet per minute for each person in the house to have healthy air and the right amount of oxygen. Natural and mechanical. What is natural? You're opening a window, that's ventilation. You have already holes in your house, that's ventilation. Or you can use mechanical vents. You just put a vent in there like the bathroom vent or the kitchen vent. The drawback of that is you will lose some heat because you're sacrificing hot air and bringing in cold air. There are some heat exchangers that you can buy that will soak up some of the heat before it leaves the house. So instead of discharging air at 70 degrees, it will be at 30 degrees, so you get some kind of heat back. Transmission, it has to be through a medium, which means it has to be through a material, either through the walls, windows. I would say we talked about windows for a week. We said windows are the worst enemy because they transfer a lot of heat, but there are ways around it. Doors can be an issue because again they open and they're large. So opening the door will let a lot of air out, a lot of air in. So there's going to be infiltration and also transmission through the door panel, unless it's well insulated. Floor and ceilings, some of the largest areas in the room. The largest area in this room is the floor and the ceiling. If they are not well insulated, you will leak a lot of air through that. I mean, a lot of heat from that. Most of the ceiling, because hot air rises, so you lose a lot of heat from the ceiling. And that's why insulating the attic is very, very important. For the floor, if you have wood floor or ceramic floor, you will lose a lot of heat. That's why your bathroom floor, if it's ceramics, is very cold. Your kitchen floor probably is cold. If you have carpet and padding, probably you have less heat transfer to the floor. If you have slab or concrete, you will lose a lot of heat, but there are ways to reduce that. So heat transfer, transmit required, we have to know the material properties. What is it? Is it wood? Is it concrete? What kind of insulation is there? So material properties is important to know how is the heat going through the wall. And we need to know the heat transfer law, which is what? Somebody. What is the heat transfer through a wall equation?
Area times.
Q equals
Delta T times.
Q equals
Area
the area
times
U times the delta T.
Delta.
Oh, it was right.
That's the general equation for heat transfer. And again, it mushrooms into a lot of things, but this is the main equation. Design and outdoor temperature. That is the delta T. So we need to know the area, the material, and the heat transfer rate. I mean the temperature difference. And we said again, when we did the project, probably you have learned that if the room next to you is the same temperature, there is no heat transfer. There has to be a temperature difference, even if it's 1 or 2 degrees. If there is no delta T, there is no heat transfer. If this goes to 0, if you multiply anything by 0, it's 0. This goes to 0. And that brings me to the topic that I want to talk about, which is insulation. Insulation is a big topic. Again, it's a big business. I know a lot of people who are just in the insulation business, and somebody will be thrilled to tell that if you tell them that I can cut your heating bill by half, and it does happen. I had a couple of students here who went and insulated their houses and put some films on the windows, and they were able to cut their heating cost by half. And again, the average person does not notice these sort of things, but now you are aware of where you are losing heat. So you can cut your heating loss by half, and you can go to your house and observe what are the areas where you are losing heat and try to work to fix that. So insulation. So let's do an example for insulation here. This is very wordy, but we'll try to walk through it step by step. You did a heat loss calculation. Realize that our room loses 4,000 BTU per hour. So let's write this down. The room has only one wall facing the outside. So where are we losing the heat? From that wall. Let's say the room is sandwiched between third floor and first floor, and they're both heated. So you know you're only losing heat through that wall. The area of the wall is what? 8 by 15. 8 is the height, times 15. The wall U factor obtained from the H22 is 0.45. You did the calculation, you find that this wall is 0.45, it's the U factor. The inside temperature is kept at 70 and the outside is 10. So this
Well, hi, quick question. What if you get a negative number as the delta T?
You flip it.
Flip it.
T was the highest, the higher minus the coldest. So, what if this, good question. So, let's say that the outside is 70 and the inside is 70 and the outside is minus 20. So that will be 90.
Oh,
Because you're gonna go 70 all the way to 0, then another 20, so the difference between them is 90. Make sense? No?
No,
Okay.
70 minus 20.
So this is 0 degree. This is
Yeah, true.
minus 10,
Negatives make it
minus
positive.
20.
Oh,
This is 10, this is 20, and this is 30. Let's go all the way to 70. So from here to here, that is 70. And then you minus 20. So you want the entire degrees from here to here.
Two negatives make it positive.
Yeah. If you want to go mathematical, 2 negative make it positive. If you want to visualize it, look at the thermometer. This is how big is the temperature difference. So what is the insulation R value if you need to reduce the heat by 50%? Let's look at that. So first of all, I want 50% of Q. So that's 4,000 times 50%. So times 0.5. I'll give you 2,000. Okay? Make sense so far? Let's work it out. I need to know what is the resistance of the wall. First, let's look at the equation sheet I gave you. You see the equation here that says R insulation from the corner. That is what we're going to, that's what we will use. So I'll put the equation down that says R insulation equal area times delta T over Q minus R wall. Okay? I have this, and I have this, that's what I need. What is R wall? No, R resistance. The wall. That's the U. Yes, 1 over U equal 1 over 0.45. What is it? What is that? Please go to the calculator.
2.2.
2.22. Okay. So now I'll carry on. Fill in the blank slowly. 5 times 8, that's 40, times 60 over 2,000 minus 2.22.
Negative 1.2.
I hope I don't get,
It should be 120 times 60.
huh?
Should be 120 times 60.
So it's 120?
Yeah.
Okay.
One point three eight.
Why would it be 120?
So it's got 1.38. It's the R value. So probably you're not gonna find 1.38, you're gonna go to what, 1.5? So this means approximation of 1.5. That's doable, that's cheap. You'll go and put that and you will reduce the heat loss by 50%, that's a lot.
So that's how much insulation
You have to add.
R value
Yeah.
you would add? Okay.
Yeah. And again, that, yeah,
I know it sounds kind of like sounds dumb, but like in like the real world, like are we gonna have to sit there and like write down all these numbers, or is it just gonna be like,
A calculator.
yeah?
no, this is why I'm explaining that to you. In the real world, probably somebody will tell you, go get some R5 or R6. But you might be wasting money if you don't know what's actually happening there. And the research is expensive. So usually in the field, people just eyeball it. But that's not good.
Yeah.
Eyeballing is not good. When you, this is going to be cheap. It's gonna be a film. You know, so if somebody's gonna go and buy those baths and stable them for no
I
reason.
mean, shit, I wouldn't want someone eyeballing my
Huh?
Like, I wouldn't want, like, if someone was doing my house, I wouldn't want someone just eyeballing and guessing.
Yeah,
I wanted to-
yeah. You want to be accurate because again, it's going to look ugly. He's gonna charge you for it, and this is how they make their money. This 1.5 is not a lot, and sometimes I'll show you now how it's not even important. Oh, I'm gonna put insulation there. No, it's not gonna do anything, and I'll show you how. And this is how a lot of people make their money, and it's not fair. But with this simple thing, you understand that it's 1.5. He's gonna put R6 there. He's gonna charge me $500 with labor, and it's going to look ugly. He's gonna massacre my wall. I don't even need it. That's what happens with eyeballs. This is the problem. And yeah, you just dump insulation in it. And I will show you also how sometimes insulation can hurt. So we'll see. So, it's a different one? Yeah. So that's another example. Let's try this together by yourself and see if you get 0.71. Let's try it out. Same thing. The part that you find tricky is reduction by 20%. So if you're buying a t-shirt for $100 and it's 20% off, how much you paying? $80, right? So.
supposed to get?
Huh? They are installation.
I know, what's
We
it supposed to be?
We divided by like the BTU hours we want to get or the BTU hours.
You got the BTU hour you wanna get, which is here.
1232.
1232.
I got 11.4.
I'm sure there is an app for discounts because this is something you're gonna face all the time when you go to buy clothes or buy anything on sale. 30% off. So how much I'm gonna pay? I'm sure there's an app for that.
What do you get the point
Huh?
eight? Times it by point seven.
Yeah.
I got 0.8.
If it's 30% off, yeah, it comes by 0.7. So the same thing here. So they'll tell you 27% off. They try to confuse you. So you go there and the cashier, they have to do the math for you.
Well, that's all you're doing is getting rid of the 20%.
Yeah, yeah.
Oh.
Yeah, that's it.
Overtime. Yeah. Yeah.
But it gets, it can get confusing a little bit. I understand why.
So
Where did you get
overtime.
0.8?
Huh?
I'm glad I went outside.
Point eight, I just multiplied by, the deduction of 0.2, which is 20%. That's one way to do it, and there's another way to do it here. Or take away 20%. So this is this is the 20% of 15.40. I mean, 1540. This is 20%, and I subtract that from the original.
Yeah.
Or you can multiply by 0.8. Everybody got 0.71?
Yeah.
If you did not, raise your hand and I will look at your work.
Well, 15 times 0.02 is not 0.71, so where are you getting 0.71?
Ah, this is when you do that. You get that number and you put it here.
Oh, okay, I got you.
Yeah.
I was putting the wrong one there. Okay. That's a lot of work.
Well, if necessary.
What's it come out to?
0.7? 1?
I got 0.7, all right. I'm with-
0.7 is good.
I see where it's.
You gotta subtract.
Yeah, okay. I don't think this is right. When you do percent, that means like it's minus 0.02. Now, if you wanna do it right, not the same number. If you wanna do
Both
it,
times, I thought it was both times.
So you're gonna do 50, 40, minus 15, 40 times 20%.
I got 0.72.
Because you're taking out, you do the parentheses, taking 20% out. Okay?
So we can't make things.
You think you can do that one day? If you forget, at least leave your notes with you, put it in somewhere you know how it's done. So when somebody tells you that what installation is needed, you know. And again, that's why you get paid a lot of money doing this. And by the way, these jobs are really, really high paying. Let's start off by 60, 70. If you can know this stuff, seriously, you'll make really good money. Because again, nobody wants to do it. Question?
What happened again after you split it 20%? You pointed over here, but
I put, I'll do it now. So I'm gonna do
I see a cliff notes version.
our installation. What is the area? 80? What is delta T? 55. And 1232 minus.
Do it a bunch of times.
What is the R wall?
Yeah.
You gotta just keep doing it, just to get used to it.
1.3, 1 over. Yeah, 2.85.
1.7.
That's 0.7. 0.72. So R1 will be enough for that. Would I bother? Not really. With that low inspection, I would not bother. Just not put it in. It's not worth the money. Okay, I'll spend 10 minutes. Everybody got that?
Yeah.
You sure? No. Raise your hand if you didn't get it.
Gonna have to go over it.
Okay.
Can you just get a couple like practice problems?
Yeah, we'll do it at 1:30. I'll give you other problems so we can do it more and more. And trust me, again, this is really, really good job to do, good thing to do, because a lot of people looking for technicians who can do that. You know, and it plays very well, and as you can tell, it's not that difficult. Yeah, yeah. We'll do a few practice problems in the afternoon. How you do it until you master it.
All right, what's the 2.85 come from?
2.8. That's 1 over. That's the out of the wall. 1 over 0.35.
Over.
Okay. This is if to understand deducting percentages. I'm trying to explain that in case you never knew. In case you go to Walmart and they tell you it's 50% off or 35% off, and the thing is like 147, and you want to know how much you're gonna pay, so you go to the scanning machine and it does that for you. And so you can do it. You understand what's happening. If 1% is 1, 50% is 0.5. 38%. Percent means per 100. Percent. So cent is 100. So percent. 38 is 0.38. That's out of 100. So 0.38. The remaining value is what I'm going to have. It's 1 minus the fraction, because I'm subtracting the fraction, right? Whatever I want to take out. Example. 3,000 minus 30%. If 30% is 0.3, then 1 minus 0.3 is 0.7. You can just multiply by 0.7 and you get the number. That's one way to do it. Whatever works in your mind, whatever you find it easy. People do things differently in their head. Or you can do 3,000 times 0.3, which is discount rate, it's 900. Then you subtract that from the original. Like how you calculate tip. She should be supposed to do it.
No, they put it on.
People
the
are
receipt.
dirty though.
Yeah, because people can't do it. 20% is not that difficult. For each $10, give $2.
This is America.
Give it
I'm doing math when I'm going out to eat.
Like seriously, it's $2 been $10. Huh?
I went to a restaurant, they lied.
They
I
lied.
checked it, it was not 20%, it was more.
How much more?
I mean, it was probably like an extra 5% or something, but still, like,
5% is a lot.
yeah, like, no kidding.
Like,
I was mad, I was like, what's this?
30, man.
That is. Huh?
Oh, 5%.
Extra?
Yeah, yeah.
It's not a mistake. It's not a
Yeah,
mathematical
at that point, you wouldn't
mistake.
get a tip.
Yeah.
Paying 20%.
Yeah. So, tip. So when I first funny story. Okay, we'll stop here. Funny story.